The question that you see on the screen is one of the most difficult questions that appeared on JEE Advanced 2026. Both AIR1 Shubham Kumar and AIR2 Kabeer Chillar got this question wrong in their examinations. Watch this video.
कोई चैट में वो वाला क्वेश्चन पूछ रहा है जो इस साल उसमें आया था, हम दोनों का गलत था, एडवांस में आया था मैथ्स का। यस, हाँ, ये तो करना चाहिए, हम दोनों का ही गलत था। एक बार पेपर टाइम सबसे ज़्यादा टाइम इसी पे लगाया मैंने।
हाँ, मेरे को पता था ये मेरे से नहीं बनना है, तो मैंने ये छोड़ ही दिया था। अगेन एक आई थिंक ये एक एडवाइस हो सकता है कि जो सवाल तुम्हें दिक्कत लग रहा है कि इसमें तुम कुछ भी सोच लो तुमसे नहीं होने वाला है, उसको छोड़ दो, या फिर अगर लास्ट में अच्छा खासा टाइम बचा हो तो फिर उस टाइम पर कुछ नया सोचने की कोशिश करो। बीच में फालतू का टाइम देना आई थिंक बेकार ही है उस पर। तो अगर इसको एक्सप्लेन करना है तो
एंड में राउंड मेरे पास आई थिंक 30-35 मिनट्स बचे थे, तो तब मैंने शुरू किया था करना, और अराउंड जब 20-21 मिनट्स बचे तब खत्म हुआ था ये, तो पूरा 10-15 मिनट लगे थे मुझे इसमें।
Okay, so you have gone through the video, and now I'm not here to comment on their preparation or on their scores or anything. But what I wanted to show you was that this question was very difficult even for a first ranker and second ranker. All right. So what is missing in their preparation? So firstly, statistics was not part of JEE Advanced for a long time, and now it is included. So you started seeing these questions in your exam, and this concept on equivalence relation is not discussed in any famous reference book, or maybe it has been discussed and we ignored it because statistics was not majorly a part of JEE Advanced examination. All right. So I see there is a lack of understanding and there is a gap in understanding for this particular concept, and hence I decided to make this video. And your takeaways from the video of these first and second rankers should be that you might have noticed that Kabeer mentioned that he finished the paper and he had still 35 minutes time left, and only then he tried this particular question, that too for 10 to 15 minutes. So you should draw an inspiration that he was able to solve the paper so quick and he has so much time left to solve these kind of good questions. So imagine the level of preparation. So that is something that you should be inspired about. And one more thing is that these type of questions are meant to be not attempted in the examination hall, as Shubham rightly pointed it out. All right. So with that, let us go ahead and see what the question is. You have a set which contains the first 10 natural numbers, basically 10 elements, and it is given that X is a set of all equivalence relations such that the equivalence relation R has exactly 42 elements. So you have to form different equivalence relations and then count all the equivalence relations which has exactly 42 elements and put them all in this particular set X. Now, I have a question for you. What are the maximum number of elements in the equivalence relation R? So, to answer that question, let me show you something. So, let us say you have only 2 elements in the set. So, these are the 4 elements that are possible in your relation. And if you put all these 4 elements in your relation, it will definitely become an equivalence relation. So the maximum number of elements are 4. All right. And if you have 3 elements in your set, the maximum number of elements will be 9. And the relation formed by using all these 9 elements will definitely be an equivalence relation. You can check it out. I don't want to prove why it is an equivalence relation because I assume you're all well aware about it. All right. Now the equivalence relation formed by using 4 elements will have a maximum of 16 elements. All right. So your set has 4 elements and if you form an equivalence relation which has maximum elements, then the number of elements in that equivalence relation would be 16. Similarly, for a set which contains 10 elements, the maximum number of elements possible are 100. Now, let us go back to this particular example. So I wrote a relation here. So this particular relation. So this particular relation is an equivalence relation because it is a reflexive relation, symmetric relation, and a transitive relation. So the relation which contains all these 9 elements is an equivalence relation. So it has 9 elements. But the relation formed by using only these 3 elements is also an equivalence relation. And the relation formed by using these 5 elements, so this is also an equivalence relation. You can check it. It is reflexive, symmetric, and transitive. So your set has 3 elements and you are able to form equivalence relations which contain 3 elements, 5 elements, 9 elements, or maybe some other value also. So the bottom line is that when you have a set containing specific number of elements, you can form equivalence relations which has different cardinalities. So the cardinality of this equivalence relation is 3, the cardinality of this equivalence relation is 5, and the cardinality of this particular equivalence relation is 9. So, and this is the maximum cardinality that you can achieve. Alright, now I have a question for you. So for this particular set, what is the minimum number of elements that can be present in the equivalence relation R? So let me know the answer in the comment section. Now with that, let us proceed. So we have already discussed. So if you consider this set, this is an equivalence relation with 5 elements and this is an equivalence relation with 3 elements. Now, since you have 3 elements, you are able to construct all these equivalence relations. Alright, but what if you have lot of elements? More than 10, more than 20. How do you do it? So we are going to answer that question now. So consider this set and break it into disjoint sets. Here I broke it into 2 sets. And now these 2 sets are disjoint. And when you take the union of these 2 sets, you will get the original set. Alright. Now what I am asking you to do is consider the first set and write the equivalence class for the first set. So equivalence class is this particular set which contains 1, 1. For a set with 2 elements, the equivalence class would be this, the set that contains all these 4. And for a set with 3 elements, the equivalence class would be this, the set contains all these 9 elements. For a set with 4 elements, equivalence class would be this, the set that contains all 16 elements. Alright. So now the equivalence class for this set is this, and for this particular set is this. Now when you take, so once you write the equivalence classes for these 2 sets, you take the union of these 2. You take union of these 2 sets, then you will get this. Alright, and if you carefully observe, this is an equivalence relation. Alright, this is an equivalence relation. Or it is not necessary that you break the set this way. You can break the set this way also. If you check here, so this particular set and this particular set, they are disjoint, and when you take the union, you are getting the original set. Now for 2, this is the equivalence class. For 1, 3, this is the equivalence class, and when you take the union, you are getting this particular thing. And if this particular thing, and if you carefully check, this is an equivalence relation. And it is not necessary to break the set into 1 element and 2 elements. You can even break the set into 3 disjoint sets such that the union gives the original set. And for this, the equivalence class for this would be 1, 1, for this would be 2, 2, for this would be 3, 3. And when you take the union, the resulting set that you have is an equivalence relation. So now you understood how to break a given set into multiple disjoint sets such that the union of those disjoint sets is the original set. And after breaking the set into disjoint sets, you know how to write the equivalence classes. And once you write the equivalence classes, you have to take the union of all of those and form a relation. And that resulting relation will be an equivalence relation for sure. Alright, so this is the concept that you have in the back of your mind. Now let us go back to our question. So this is the set given to us. Now the first step is to break the sets into multiple disjoint sets. We don't know how many sets. Okay, we don't know how many disjoint sets. Let us say we are breaking the set into n different sets such that the union of all those disjoint sets is the given set S. Alright, now for the first set, let us say it has A1 elements. So if you consider in the first set, the equivalence class, it has A1 elements. So A1 is 1. Alright. And for the second set, A2 elements, third set, A3 elements, and nth set, AN elements. So if you add them all up, so you should get 10 because the given set has 10 elements. Alright. And you are breaking that into disjoint sets. Now again, using these A1 elements, you can form A1 square. You can get A1 square elements in the equivalence class. So from one element, we got 1 square. From two elements, we got 2 square here. 2 square elements in the equivalence class. If you have 3 elements, you will get 3 square elements, all of these. If you have 4 elements, you will get 4 square elements, which are all of this in the equivalence classes. So for the first set, you have this many elements in the equivalence class, this many in the equivalence class for the second set, for the third set, and for the fourth set. And if you add all of them up, you should have 42 according to the question. And so if you consider A1 is equals to 10 in this case, alright, so your 10 square will become 100 and all your A2, A3 and so on AN will become 0. In that case, you will achieve the maximum number of elements, which is 100 in your equivalence relation, but they're asking for 42. So therefore we have this particular equation. Now we have these two equations. So now carefully observe. All the AIs, A1, A2, A3 and so on AN should be less than or equals to 6, because if one of them is 7 or more than 7, in this relation left hand side will become greater than 42. So therefore that should not happen. So AI should be less than or equal to 6. Since we are dividing into disjoint sets, each set must have at least a single element. So therefore AI greater than or equals to 1. So without loss of generality, let us assume this. A1 is the maximum element. A2 can be equal to that or less than that. Similarly, and so on till AN. Now let us consider the first case. What is the maximum value possible for A1? So that is simply 6. So I am considering that. When you put A1 is equals to 6, so this equation will give you this A2 plus A3 plus and so on AN is 4. And the second equation, this becomes 36 and this part should become 6. So I have written that here. We have these two. So the sum should be 4. The sum can be 4 when you put A2 is equals to 4 and remaining all are zeros, or 3 and A3 is equals to 1, remaining all are zeros. 2, 2, all the remaining values are zeros. 2, 1, 1 and all the remaining values are zeros, or 1, 1, 1, 1, all the remaining values are zeros. Only in these cases the sum will be 4. Alright, if you can check, 4, 3, 1 is 4, 2, 2 is 4, 2, 1, 1 is 4, 1 plus 1 plus 1 plus 1 is 4. Now, you have one more condition. Sum of squares should also be 6. So if you check here, sum of squares is 16. So this is not a valid case. This is not a valid case. This is not a valid case. This is a valid case. And this is not a valid case. Okay, we started with the maximum value for A2. A2 and we started going down because we had this assumption in the beginning. All right. Now, so this is one valid case. We got one valid case here. Now let us go ahead. So we already considered a1 is equal to 6, which is the maximum value. Now let us consider a1 is equals to 5. When a1 is equals to 5, a2 plus a3 plus and so on, an should be 5. And a2 square plus and so on, an square should be 42 minus a1 square, which is 25. So that is 17. So now you have to get the sum of 5. Sum of 5 can be achieved using 5 0 0 0, 4 1 0 0, 3 2 0 0, 3 1 1, 2 2 1, 2 1 1 1, 1 1 1 1 1. But in all, we have another condition. The sum of squares should be 17. Here it is not 17. Here it is not. Here it is not. Here it is not. It is not. It is not. So this is the only valid case. So this is for a1 is equals to 5. So let us assume a1 is equals to 4. When a1 is equals to 4, this sum should be 6 and sum of squares should be 26. So for sum to be 6, you can write 6 0 0 0. But you should not write this because we already assumed a1 is the greatest integer. But here, if you write this, a2 will become your greatest integer. So you should not write this. Similarly, you should not write this as well. You can start from here. So 4 2 0 0. That way your sum will become 6, or like this, or like this, or like this, like this, like this, like this, like this, or like this. All these cases. Now if you carefully observe, your sum of the squares started decreasing from top to bottom. So you observe how I wrote the values. Now if you check, your sum of squares started decreasing. 4 square is 16, 2 square is 4, that is 20. Okay, but you need the sum of squares as 26, which is not possible. So it is either 20 or less than 20. So here you will not get any valid case. Similarly, you can try for a1 is equals to 3, a1 is equals to 2, a1 is equals to 1. You will not get any possible cases. So far we only got two possible cases that satisfies these two equations. Alright, the first possible case is this 6 2 1 1. We don't have to worry about zeros. 0 means the number of elements in the set is 0. Alright, that means you don't have any set. You can divide the set with 10 elements into one set with 6 elements, another set with 2 elements, another set with 1 element, another set with 1 element. Or you have one more here, one more case here. a1 is equals to 5 4 1. You divide the set into 3 different sets. First one containing 5 elements, second one containing 4 elements, third one containing 1 element. So these are the two valid cases. So we already discussed we will not get any valid cases for 3 2 1. So now these are the two valid cases. Now first set should have 5 elements. So total you have 10 elements, so you can choose any 5 elements in 10c5 ways. Second set should have 4 elements. We have already chosen 5 from the 10, so 5 elements are left. So you can choose 5c4, and whatever remaining element is considered as a different set. When you solve this, you will get 1260. Now coming to this, first set should have 6, so 10c6. Second set should have 2. So we already have chosen 6 elements, so 4 elements are left. Out of those 4, you choose 2, 4c2. Now 2 elements are left. How do you divide these 2 elements into 2 different groups? So you can first choose 1 element, write 2c1, but then you have to divide it with 2. Why do you have to divide it with 2? Let's say you have 2 elements and you have to partition them into 2 different groups. So when you first choose this element, okay, so you have 2c1 ways to choose the first element. All right, 2c1 ways. So let us say you have chosen b1 first or b2 first. Now to choose the second element, you have only one way. But then these two are same, b1, b2, two groups. First group has b1, b2, or first group has b2, second group has b1. These two are essentially same. That is why we have to divide this by 2. All right, I hope you are aware of this. This is an NCERT concept. So when you solve this, you'll get 1260 here. So total 1260 cases here, 1260 cases here. So it is 2520. I hope you are able to understand this particular concept. And as a homework, I'm giving one question which you can find in the quiz section of this video. So YouTube added this new feature where I can add quiz questions. So I am adding 1 or 2 quiz questions along with this video. So make sure you go to the quiz section and answer those questions to strengthen your understanding about this particular concept. I hope you have liked this video. If so, give it a thumbs up, share it with your friends, and subscribe the channel for more such videos. I'll meet you in the next video. Thank you.